All right, folks. So we're halfway through our unit on quadratics. And so far we've dealt purely with quadratic expressions, which we factor, and quadratic equations, which we solve. The last thing we need to look at then is quadratic functions, which we graph. So a quadratic function is a function of the form f of x is equal to something like x squared plus 5x plus 6. That's an example of what we're dealing with here. It is a function, takes an input, gives an output, and how does it find that output? It uses a quadratic expression to go from input to output. So for example, for this particular guy, if I wanted to graph it, I could set up a table of values. I could take input values x and output values f of x, and I could try to put some things in. Like, let's say I started with 0. Well, then I'd be doing 0 squared plus 5 times 0 plus 6. But of course, that's just 0 plus 0 plus 6. So that output would be 6. Or I could try 1. Then I'd have 1 squared plus 5 times 1 plus 6, which is 1 plus 5 plus 6, which is 12. Or I could try negative 1. So that would be negative 1 squared plus 5 times negative 1 plus 6. But that would be 1 minus 5 plus 6, which would be 2. Or I could try something like negative 2. Then I'd be doing negative 2 squared plus 5 times negative 2 plus 6, which would be 4 minus 10 plus 6, which would be 0. And I could keep going here, and I'd find that if I tried negative 3, I'd also get 0. If I tried negative 4, I'd get positive 2. And so based on that table of values, I can draw the graph of my quadratic, and it looks something like this. This shape of the quadratic, which is kind of like a triangle with bent sides, has a name. We call it a parabola. And every single quadratic function has a graph, which is a parabola. Sometimes those parabolas point upwards, like this one does. Sometimes the parabolas point downwards. Sometimes the parabolas are skinny. Sometimes the parabolas are much more fat. But in either case, or in every case, the graph of a quadratic is going to be a parabola. Our goal in this unit is to be able to look at a quadratic function and without worrying too much about something like a table of values, to be able to create the graph of that quadratic function. So how are we going to do that? Well, we're going to have a bunch of strategies, but the main one is this. I know that if I have some sort of quadratic, let's say something like x squared minus 3x minus 10. I can factor that into x minus 5 times x plus 2. And if I have some sort of quadratic equation, like x squared minus 3x minus 10 equals 0, then I can solve that, and my solutions are x equals 5 or x equals negative 2. So these numbers that show up all the time, the 5 and the 2, these are the roots of the quadratic. This is the first root of the quadratic, and this is the second root of the quadratic. When I draw a graph of a quadratic function, those roots show up yet again. When I draw a graph of a quadratic function, its x-intercepts are the roots. That is to say, I have an x-intercept at negative 2, I have an x-intercept at 5, and the quadratic is the parabola which goes through those two intercepts. So we'll take a closer look at this on Monday, but the point is, if I can factor or solve the quadratic, if I can find those roots, I can also graph it. And in order to graph it, I'll take advantage of the fact that the x-intercepts of the graph are the roots of the function. All right, so we'll take a look at this on Monday.